Hello, geometry, and welcome to lesson 4.3, proving and applying the SAS and SSS congruence criteria. So when we try to prove triangles congruent, there are going to be multiple ways we do that, and SAS and SSS are two of those ways. When you see the letter S, you should be thinking of the word side, and when you think of the letter A, you should be thinking of the word angle. Right, so SAS, 2 sides and an angle. SSS, 3 sides. So today we're going to try to prove these ideas, which is going to be a little bit cumbersome. It's going to involve some transformations. But to me, more importantly, is can you apply them? Okay. All right. So example 1 here. Given 2 triangles with 2 pairs of sides congruent and the included angles congruent, verify that the triangles are congruent. So this idea of 2 pairs of sides, so 2 pairs of sides and included angles, that is the SAS, 2 sides and the angle in between, the included angle. So you can see in this picture that we are given, right, ST and YZ are congruent, 1 dash, angle S and angle Y are congruent, angle, and then RS and XY are congruent, 2 dashes, right? We want to try to make one triangle become the other triangle. So we're going to move triangle RST so that it becomes, so that it is mapped to triangle XYZ. Okay? So I'm going to do it up here. If you draw this picture, draw your triangles up more separate, but mine are here, so I'm going to work with them here. Okay. So step 1, I am going to translate. So again, we're going to use rigid motions. Preserves side length and angle measure. I'm going to translate triangle RST so that S corresponds with Y. And we're going to let Y be called S prime. So I'm going to take this triangle and slide it this way so that Y is now also S prime. And I'm going to draw triangle RS. So here's my R prime, and then out here there's my T prime, and there we go. And again, R prime S prime is the same as RS, S prime T prime is the same as ST, and this angle is congruent. So that's step 1. So I have S and Y corresponding, right? That's my goal, is to get all 3 of my corners to correspond. All right, step 2, I'll do it in blue. So step 2, now I'm going to rotate triangle R prime, S prime, T prime about point Y, right? And I'm going to do this so that now I'm going to get R prime, R double prime, S double prime to be mapped onto, or to get R double prime, S double prime to be mapped onto segment XY. And what this means is that X is now going to equal R double prime. So I'm going to rotate this around all the way. I'm going to go this way counterclockwise so that S stays put. So this is still S prime, but now R came over here. So now this is R double prime, and now T is shooting out to the left somewhere, right? So you kind of have to visual this, right? So if I'm up here, I spin this all the way around, yes. So then T is going to come out this way, and there's going to be T double prime, and there's the connection of R double prime, T double prime. And again, we still know that ST and S prime, S double prime, T double prime are congruent. We have the markings here, and we know that these angles are congruent still. Okay. And now if you notice here, we have this angle congruent, we have these sides congruent. This is similar to like something we did last lesson, but I'm not going to get into it. We're just going to do a reflection now. So step 3, I'll do it in purple. So now we're going to reflect. And we're going to take triangle R double prime, S double prime, T double prime, and we're going to reflect it about segment XY. The segment in between these two triangles, segment XY. And this is going to be so that S triple prime T triple prime, that segment, is equal to YZ, which would mean that Z lines up with T triple prime. So let's see. T double prime goes reflected over here. Now T double prime is T triple prime there. This is now R triple prime, it stays put, and this is now S triple prime because it stays put. And here is your final triangle. Those angles are congruent. They're mapped completely on top of each other, and what you did was you just did a set of rigid motions to make triangle RST become triangle XYZ. So our conclusion here is we have a composition of rigid motions exists. I could spell exists. Exists for triangle RST to be congruent to triangle XYZ in this picture. And what we did here is we just confirmed that for two triangles to be congruent, all you need to know is that two sides and the angle between those sides is congruent. Okay? So again, if this stuck, great. If not, that's fine. You walk through it. Now let's actually apply it to some problems, right? Okay. But first, let's talk about the actual theorem. So here's the actual theorem here. Okay, so it says the side angle side congruence criterion. If two sides in the included angle of one triangle are congruent to two sides in the included angle of another triangle, then the triangles are congruent. So it's two sides and the included angle congruent. Two sides in the included angle, then the triangles are congruent. So again, over here, you have this first pair of sides, side 1, side 1. You have the included angle here and here, and you have the second pair of sides, side 2 and side 2. That would then prove that those two triangles are congruent. Now you might be asking, okay, if those three parts are congruent, what about the third side and the other two angles? Well, I'm glad you asked that question, because a lot of times when you do proofs, you use this idea called corresponding parts of congruent triangles are congruent, CPCTC. I had a geometry teacher, Mrs. Halas. She always wore a lot of red lipstick, and I can still remember her saying CPCTC. She enunciated very well. It's burned into my brain. So CPCTC, right? Basically what it says, if you have two triangles that are congruent, then each pair of its corresponding sides and each pair of its corresponding angles is congruent, right? So every triangle has three pairs of sides, three pairs of angles. So here, AB is congruent to XY, BC is congruent to YZ, and AC is congruent to XZ. Three pairs of congruent sides. Three pairs of congruent sides. You also have three pairs of congruent angles. Angle A and angle X, angle B and angle Y, angle C and angle Z. Three pairs of congruent angles. And there we go. So it's powerful if we can prove that the two triangles are congruent, and those listed pairs are right up here. CPCTC, huge idea. Okay. All right, let's do one example here, and then we'll move on. All right, so it says, Ali cuts two triangles from a rectangular piece of metal along the dashed line to make earrings. How can Ali show that the earrings are the same size and shape? Okay. So basically what we're trying to do here is we're taking this piece of rectangular metal, we're breaking it into two triangles. I'm going to draw those two triangles right over here. So triangle BAD and triangle BCD. And we want to prove that these two triangles are congruent, that they're the same. Well, let's recall about a rectangle. All right. Now, again, I think this book takes some liberties, thinking you might know some things. So, first of all, in a rectangle, the opposite sides are congruent, right? So, this pair of sides are congruent, these pair of sides are congruent. Okay. The second thing is a rectangle has four right angles. 1, 2, 3, 4. Okay, so let's talk about things in our picture. Let's use the opposite sides idea. So in the original rectangle, BA and CD are a pair of opposite sides. So BA and CD would be congruent. So I'm going to call this for sake of correspondence. So AB is congruent. Now A is where the right angle is going to be. So I have to go is congruent to CD. Right. So this would be my first step. I'm just going to do kind of like a hybrid two-column proof. So this is because the opposite sides are congruent. That's fine. We know it's a rectangle. Okay. We can do the same thing with the bottom side, AD and BC. So step 2, AD is congruent to. So now again, AD and CB. And that's the same thing. Opposite sides are congruent. Okay. So in our picture, there's our two pairs of sides. So if we're trying to use SS, here's side 1, here's side 2. So the angle in between these two sides would be angle A, and the angle in between these two sides would be angle C. Well, angle A and C better be congruent. Well, they're right angles. Right? It's a rectangle. They're right angles. And we learned a theorem back in, I think it was topic 1, that all right angles are congruent. All right angles are congruent. And you have now used side angle side to prove that these two triangles are the same and the earrings would be the same shape. So your last step, triangle ABD, this first triangle, triangle ABD, and now corresponding ABD CDB is congruent to triangle CDB, and that would be side angle side. And I like to throw the congruent symbol there. And that would be an example of a proof here. Okay. So aside from the rectangular properties, hopefully you understand the idea of like if we're trying to prove two triangles congruent and we're going to use side angle side, you got to get those two pairs of congruent sides and the angles in between. All right, so I'm going to stop the video here. We got side, side, side coming up in the next video.